Hello and welcome to Los Alamos National Laboratory's Math and Science Academy. In this thread we'll be talking about the 5th grade standard for numbers in base 10, and we'll be focusing on part B of that standard. Part A of that standard is about the place value system. Part B is about performing operations now with multi-digit numbers and with decimals to the hundredths. NBT.B.7 and 6 are about basically multiplying and dividing. So B.7 is the culmination of pretty much the 5th grade numbers in base 10 standard. We're looking at adding, subtracting, multiplying, and dividing decimals to the hundreds with all kinds of ability to understand through models, drawings, place value strategies, operations, a lot of procedural things, and also being able to explain the reasoning and do strong written mathematics. So it's really a big standard, and in order to keep this thread more concise, we're only going to focus on dividing. We're just going to look at dividing decimals to the hundreds, and we'll look at mostly properties of operations, a little bit in place values, and I'll do some review of these other models to help you see how that relates to what we'll be doing. The learning goals for this thread are that the student will be able to visualize and understand the process of dividing multi-digit decimal numbers. And again, we're just focusing on division, even though the standard itself, NBT.B.7, includes addition, subtraction, and multiplication. The second goal is to use place value strategies and recognize when the strategies are applicable, and we'll show a little bit of that. And finally, the student will communicate their thinking with precision. Before we go on and look at this standard in detail at the 5th grade level, let's look at a few visual approaches for division. These are approaches that students will have seen in 2nd, 3rd, and 4th grade to help underlie the conceptual meaning behind division. One of these is counting groups in a place value model. So for example, if we have 36 divided by 3, we take the dividend and write it in a place value model as follows. We start with columns, 2 columns, tens and ones in this case, and the 3 dots represent 3 tens in the 36, and the 6 ones are represented with 6 dots here, and so we have this number 36. Dividing by 3 involves taking all the tens we have and creating 3 equal groups, likewise with the ones. And so when we do that, we can keep track of it this way. When we take the 3 tens and break them into 3 equal groups, we get 3 groups of 1, and these are the 3 tens in our 36. With the ones, we can break them into 3 groups of 2, and we have 3 groups of 2 ones. And now what we have is 3 groups of a 10 and 2 ones, a 10 and 2 ones being 12, and so we have that when we divide 36 by 3, we get 12. This also connects back to multiplying because we have 3 12s, or 3 times 12, which gives us our 36 that we started with. Another approach is to use an area model. Let's use a different example, 11 divided by 2. We start out this time by imagining a grid, or actually drawing a grid, and we notice that when an area model has the 2 sides are the 2 factors that create the number. And so one of the sides is going to be of length 2. And so let's make a rectangle with one side of length 2. Now the question is, what should this other side length be? And we know that 2 goes into 11 5 times plus a little bit more. So we'll make that second side length 5, and we create this rectangle, which is 10 units. But we didn't want 10 units, we needed 11 units, and so we have this 1 left over. So 2 goes into 11 5 times, and that'll give us 10. And then we have 1 left over, which we can write as R1. Later we'll get to that being 1/11th. A third approach is to use the standard algorithm. And in this case, we hope that students have been connecting this standard algorithm to these diagrams and models all throughout 2nd, 3rd, and 4th grade, so that by the time they get to 5th grade, they're using this quite a lot. And in 5th grade, basically, we're mostly going to be focusing again on procedure, which is the algorithm. So here's an example. We want 86 divided by 5, and now we're going to write the dividend inside this divide symbol and the divisor outside. And the first question is to see how many times does the divisor go into this first, the highest value digit, the 8, in the dividend. And we know that 5 goes in to 8 one time. And when we multiply 1 times 5, that's the next step, multiply 1 times 5, we get 5. And that is written below the 8, and we're subtracting. Now what this 5 really is 50, because this 1 is really a 10. And that's because the 8 is really an 80. And 5 goes into 80 10 times, and that'll make use of 50 of our units. 1 times 5 is 50. So let's see what we've got left when we take 50 away from 86. We get 36. Often people write the 0 right here, or other people will just say, let's bring down the 6. I remember learning it that way. But this is really a 50, and when we're taking 50 from 86, we get 36. And now we know that the next question is, how many times does 5 go into 36? Well, it doesn't go 10 times. It goes less than 10 times. And so now we can only write some number of 1s, and the number of times 5 goes into 36 is 7. And 7 times 5 is 35. So these are 1s now. And we're going to take away our 35 from 36, and we get 1 left over. So our answer is 17 with 1 remainder, or 17 and 1/5. So, of course, later on with decimals, we can extend this and do this in decimal form. But for now, we're going to just leave it as a remainder 1, or an additional fraction of 1/5. Next, we'll look at a little more sophisticated value, this time involving decimals. This will take us up to the 5th grade level with these ideas. You'll notice also that the student at this point is expected to be looking at this from several different points of view. Concrete models or drawing, strategies based on place value, properties of operations, and relationships between addition and subtraction. By the 5th grade, the student is expected to know the procedures well, but be able to explain them and really deeply understand them from a variety of perspectives. So we'll start with one, which is to use a place value model. This time with decimals, which means that we're going to have tens places, ones place, and a 0.1s place to represent our value. So we start with the dividend, 34.8. We have 30, and 30 is represented by 3 dots in the tens place. We also have 4, and these are 4 ones, which are represented by 4 dots in the ones column. And we have 8 0.1s, which is represented by 8 dots in the 0.1s column. Our goal here is to divide this by 0.6. But what the student needs to understand, and this is getting into the place value understanding here, is that each one of these places is 0.1. So each dot here represents 10 of the units to its right. So this is 10 0.1s. One of these dark blue dots is 10 0.1s. And one of the light blue dots is 10 ones, or 100 0.1s. So this is really 300 0.1s. Well, we're going to try to divide this up by 6, and we don't have 6 groups of 100 0.1s. We only have 3 of them, And so we need to divide this up, or decompose these 10s into 1s. So we're going to reconceptualize our number 30 plus 4 plus 0.8 by taking each of the 10s and breaking it into 10 1s. And think of our number as 34 1s plus 8 0.1s instead of 3 in the tens place. Now we can break this into groups of 6 because we have some of them. In fact, we have 5 of them with 4 1s left over. But remember that each one of these is 10 0.1s. So this is really 10 times 0.6. Each of these groups has 10 times 0.6, and we have 5 of those groups. So really we have 50 groups of 0.6 instead of just 5 groups of 0.6, because each of these ones, again, is 10 0.1s. So we have 50 in there. So next, we're going to take these 4 remaining ones, and we can't divide that into a group of 6. And so we need to decompose that again, like we did with the 10s, and take each of these 1s and represent it as 10 0.1s this way. And you'll notice now we're going to rewrite this. Now we have 30 1s over here because we took 4 of them away and rewrote them as 0.1s. And we have 48 0.1s, which is 4.8. And so we still have our 30 plus 4.8, but now it's broken into groups, decomposed down to where we can divide by 6 again. So let's break the 0.1s into 0.6s, and there's one group, and now each of these is 0.6, each of these groups, 1. Here are 5 more. Here's another. You can do this in a number of ways, and then when we get to the end, we need to kind of pull these together and make our last group. And it turns out there's nothing remaining here, which is a nice clean result. And we just count these, and we have 8 of them. 3 and 5 gives us 8 groups of 0.6. So all in all, we have 50 groups in the 1s and 8 groups in the 0.1s. So we have 8 groups of 0.6, which means that 34.8 divided by 0.6 is 58. Let's do this division problem again, this time with abstract symbols that are more consistent with what we're expecting at the 5th grade level. We'll focus on properties of operations, specifically using properties of fractions. So let's begin by rewriting our problem, 34.8 divided by 0.6, as a fraction. And we do this because it helps the students understand the relationship between divisions and fractions. And it also reminds students that we can rewrite fractions with different versions of values in the numerator and denominator. In other words, we can multiply any fraction by some version of 1 and still get the same value. And in this case, we're going to pick 10 divided by 10 as 1, so that our numerator will become 348, our denominator will become 6, and we have now a fraction of whole numbers, which we can then rewrite as a long division problem with whole numbers, and the decimals are now eliminated and we're not worried about them anymore. There's a shorter way to do this, which students will understand hopefully as they go along, and that is to simply move decimal places. Moving decimal places is equivalent to multiplying or dividing by 10. Moving to one place to the right is equivalent to a multiply of 10. And so if we do that in the numerator and the denominator, we'll get the same result. This is 348 divided by 6. This is something that the more advanced students can do as they get better with this understanding. So once we're here, we have a long division problem, and again we're going to use the traditional standard algorithm to do this, and to do that we write the dividend inside and the divisor outside, and we look and decide, how does 6 go into 3? And it doesn't, but it does go into 34, and it'll go into 34 5 times. So then we multiply 5 times 6, and we get 30. But since this 5 is really a 50, it's in the tens place, 5 times 6 ends up being 300, because this is really 50 times 6. And we'll subtract that 300, because we've used up that many units, from 348, and we have 48 left. And then we see how many times does 6 go into 48, and the answer, of course, is 8. And 8 times 6 is exactly 48, so we have no remainder, and we've got our answer of 58, which is what we had before. So while we're here, I'd like to show you a shortcut for dividing with a single-digit divisor. This has been something that is so helpful as students get more advanced to be able to do a lot of quick single-digit division, that it's important to be able to introduce them to it and see what's going on. So we'll start with our problem here, 348 divided by 6, and what I'll do is I'll say 6 goes into 3 0 times, so we don't write anything. 6 goes into 34 5 times, just like we did over here. But now, in our head, we're going to say 5 times 6 is 30. And the remainder of 30 from 34 is 4. So if the students get to the place where they can do that kind of arithmetic in their heads mentally, then they can say 5 times 6 is 30, remainder here would be 4, and we'll just write that 4 right here. Instead of going through the process of doing all this subtraction, we're going to just see the remainder, and that remainder 4 gets written right here, and that's our 48. That's our 48. And then we're going to go 6 into 48, and that's 8. And we're done. Let's look at how powerful this is with a pretty complicated division here and see what happens here. Let's try 7 into 91,726.81. If we want to do this division, we can write it out. We go 7 into 9 is 1. The remainder is 2, so we write the 2 here. 7 into 21 is 3. And that's exact, so the remainder is 0. There's no 0, no remainder. So now 7 into 7 is 1. Again, there's no remainder. So we have just a regular 3 here. 7 into 3 is 0 with a remainder of 3. 7 into 36 is 5. That's 35, so the remainder is 1. 7 into 18 is 2 with a remainder of 4. So we're here at 41. And 7 into 41 is, let's see, 5 again. And our remainder is 6, because 7 times 5 is 35. From 41 is 6. Well, now we need to extend ourselves, because we could either say there's a remainder of 6, or we could say and 6/7, or we can continue out by just extending more zeros out here. So we can add a 0, and 7 into 60 is 8. That's 56. So the remainder is 4, and we need another 0. 7 into 40. Let's see, we just keep going. 7 into 40. That's 35 with a remainder of 5. 7 into 50. 7 goes 7 times to give 49, but there's a remainder of 1. 7, oh my goodness. 7 into 10 goes once. There's a remainder of 3. 7 into 30 is 4 with a remainder of 2. How long does this go? Are you familiar with sevenths? You will be after a moment. And let's see, 7 into 20 is 2 again, and the remainder is 6. And now you'll notice that back here we had a 6/0, and we put it, we we had 8. That went in 8 times. Well, this 6, 0, it's going to go in 8 times as well, and the remainder is going to be 4, and then we're going to get a 5, and the remainder will be 5, and so forth. And this whole pattern, 8, 5, 7, 1, 4, 2, it will repeat, because the numbers here are going to always be zeros. So 8, 5, 7, 1, 4, 2 will repeat, and so we'll just eliminate these two and write this as 8, 5, 7, 1, 4, 2 repeating. Your students aren't expected to know this at 5th grade, but I just wanted to show you that that's one of the powers of this single digit division, which could take a whole lot longer if you didn't know how to do it. This is also an opportunity to introduce you to one of my favorite fractions, 1/7. Most people shy away from sevenths. It's not clean, like a fourth is 0.25 and a half is 0.5 and so forth. 1/7 has 6 digits that repeat. 1/7 is 0.142857 repeating. But what's interesting about it is that in this case we have 6/7, and 6/7 has that same set of digits. If you just rotate them around, we get 8, 5, 7, 1, 4, 2 repeating. So it's an interesting thing to see how sevenths work, and it's kind of a fun pattern to point out to your students. Let's do another division problem here, this time with 2 decimal places. We'll focus once again on the abstract symbolic notation that we use in the 5th grade and focusing on the procedure. This particular example is kind of the culmination of where we hope students will be at the end of 5th grade with regard to division of decimals. So we are going to show this particular one by using fractions, and it's a common thing to do when we have decimal place division. We'll write our division problem as a fraction, and this time I want to bring in the idea of estimating your result. It's important that students have a general sense of what the answer should be, so they don't get confused by the algorithm without staying in touch with the number sense and what the answer should be. So in this example, 7.36 and 0.28, we can estimate this 7.3 as 7.25 and the denominator 0.28 as 0.25. Now, why do I pick 0.25s? First of all, they're clean numbers, kind of benchmark numbers that students are much more familiar with. But in particular, with 2 decimals, we can really think about money here. There's an opportunity to think a bit about this with something we're familiar with, which is money. $7.25 divided by a quarter, if we talk about if we round these to both to 0.25s, is something that students can wrap their head around pretty quickly and easily. 7.25 divided by a quarter. Well, how many quarters in $7.25? Well, there's one lone quarter that's here, and then $7, each of which contains 4 quarters, gives me 28 quarters. 7 times 4 is 28, plus the 1 gives me 29. So I know my answer should be in the ballpark of 29. And it's important that students have a sense of where they should be so they don't make mistakes in the algorithm and then have no ability to catch them. So we move on, and this time I'm going to, before I do the division, I'm going to do the multiply of the numerator and the denominator by 100. That's really what I'm doing here, just by moving the decimal place 2 to the right. That's a multiply by 100, and that's one of our properties of place value that's part of the standard here, is really understanding how we can use place value to do things like that. And we have 736 divided by 28. And now to get the accurate answer, we'll go ahead with the algorithm, the standard algorithm, writing it out like this with the dividend and the divisor as shown. And then we ask ourselves, how many times does 28 go into 7? Well, it doesn't. How about 28 into 73? Well, this is where number sense is really important to have. 28 is close to 30, and 30 will go into 73 about twice. student might guess 3 times, but that's 3 times 30 is 90. That's quite a bit larger than 73. So maybe we'll try 2 and see what happens. Of course, if they tried 3 and multiplied it out, they'd find that they get something larger than 73, and they'll have to go back to 2. But we get 2, and then we do the multiply. 2 times 28 is 56. And again, that multiply is something that students need to be able to do fairly quickly by this point. 2 times 8 is 6. Carry the 1. There's an extra. The 1 is because 2 times 8 is really 16. We bring the 1 up here and compose it with the 2 tens and end up with 5. So we get r minus 56. And of course, since the 2 is in the tens place, 56 times 10 is 560, which is really what our answer is here. And then we'll do the subtract, which is indicated, and we get 176. And now again, the student needs to think, well, how many times is 28 going to go into 176? Number sense is critical here, because if the student sees 28 and sees a 2 and sees the 17 as an 176 as an 18 or something because it's an even number, they might try a number as big as 9, especially if 9, they saw their estimate as 29, so they may guess 9. But this number 28 is really much closer to 30, and this is still close to 180, so 30 into 180 is really only 6. So there's some trial and error here and some real sense of what's worth trying, and the more they do it, the more practice they'll get at really understanding the sizes of these numbers. So 6 is a good guess, and 6 times 28 then, we work that out the same way, and we get 168, which is surprisingly close to 176, especially if your original guess was 9. And then we find out what's left, and all we've got is 8. And 8 can then be written simply as the remainder. 7.36 divided by 0.2 is 26, remainder 8, or 26 and 8/28. And for now, we'll just leave this as a mixed number. However, we do want to encourage students always to reduce fractions. So when we see 8/28, we really want to encourage students to recognize that those are both even numbers. We can divide each of them by 2, or in this case, because both of them actually have a 4 in them, we can simplify by dividing the numerator and denominator by 4 and get 26 and 2/7 as our final result. So here we have some examples of mathematical writing. Up here on the first one, we see pretty much the same process that we had used with writing a division problem like a fraction, multiplying by 1, in this case 100 over 100, in order to move the decimal place 2 places over, resulting in 168 divided by 12, and the answer is 14. Now this student here didn't show the process for getting here. Here's an example of someone who did show that. So how do we get from 168 divided by 12 to 14? Well, one way to do it is to basically reduce the fraction. And the writing here, I really don't like this writing here. It's not an example. It's actually an example of something I discourage, because what this divide by 2 here, what the student is basically implying is that they're dividing the top and the bottom by 2 and crossing out the 168 to go to 84 and crossing out the 12 to go to 6. And what happened there was they divided by 2. But anytime you write mathematics, it should represent what you're doing. And if we were to take this fraction and divide it by 2, we would not get this. We would get 168 over 24, because dividing by 2 is the same as multiplying by half, and we would actually change the value. So I discourage that, but it is clear what the student did. Basically, they're canceling 2 out once, they cancel it out again to get 42 over 3, and then when they divide 42 by 3, they get 14. So that's it's understandable what they're doing, but I would discourage that writing. This, in my view, is okay. They're recognizing that 4 goes into both of these numbers, and 4 into 12 is 3. 4 into here, that 4 goes into 16 4 times, into 8 twice, and there you have it. And then 42 divided by 3, again, simple single-digit division. 3 into 14 is 3 goes into 4 once. Remainder is 1. 3 into 12 is 4, and that's how we can get that 14. Over here we see an example of moving the decimal place instead of multiplying by 100 over 100, just a shortcut way of doing that. And this is, the implication here is that they're just thinking about this and going straight from here straight over to the algorithm, the standard algorithm, and writing it out that way, and then doing the necessary steps, which you can see here, to get the result, the quotient of 22. So those are some pretty concise ways, as you can see, of doing these kinds of problems, and very symbolic heavy, abstract. Again, this is 5th grade now, and students hopefully are quite strong at these procedures, but with a thorough understanding of where they come from.